My name is Colton Baldwin, and I'm going to be sharing with you guys my term report number 7. My name is Colton Baldwin, and I'm going to be sharing with you guys my term report number 7. So, in order to understand the Kamiak Butte, you have to consider its formation. And so, starting about 237 million years ago, all the continents of the world were combined into the supercontinent called Pangaea. And over the course of millions of years, it began to break apart, and that's what led to the formation of like the modern world that we know today. So the theory of plate tectonics is what gives explanation to this continental drift and merge of the supercontinent Pangaea. And so basically plate tectonics, they give an explanation for like much of the modern world, such as like mountain ranges, and they explain earthquakes. And so modern Washington that we know today didn't really begin to form until about 17 million years ago, when the Juan de Fuca plate subducted underneath the North American plate. And this caused like a domino effect. So it increased the volcanic activity in the area, and it led to a very thick layer, about 2 miles deep, of flood basalts to be deposited all over the Pacific Northwest. As time moved on, glaciers from the north began to creep forward and cover much of Washington and Montana. And as the ice age began to end, everything began to warm. And so this led to the formation of glacial Lake Missoula, which is a very important piece of Washington state's history. And so this basically formed when precipitation was increasing and Montana's river channels were filled with it. And these rivers flowed and became backed up against a giant glacial lobe, and that's what formed Lake Missoula. So the massive size of the Lake Missoula lifted the glacier up, and the ice dam released all these floodwaters into eastern Washington. And these were very powerful floodwaters. They carved much of the land, which explains a lot of like, well, I guess the land of eastern Washington. Um, so yeah, this basically is the reason why Washington looks as it does today. These floodwaters came to a stop at Wallula Gap. They were unable to pass through. And so this giant mix of organic material that these floodwaters were picking up throughout time sunk to the bottom of this backed up area. And over like a long period of time, the water slowly filtered out of Alula Gap and left this giant mix of sediment on the bottom. And over time, Pacific winds picked it up and carried it over Washington, which explains the loess soils on the Palouse. So once these loess soils were picked up and brought over to the Palouse, um, the whole area was covered in them, which is explains like the famous fertile farmlands that we have over here. And the Kamiak Butte also has loess soils on top, but it has a layer of quartzite beneath that, so it makes it pretty difficult to make into farmland, which explains why it's untouched by humans. Moving on to the second term report, this is all about climate interactions at the Kamiak Butte, and with that comes the explanation of air masses, macroclimate, continentality, topography, and these all come together to explain the composition of Kamiak Butte. So beginning with air masses are an important concept to understand. They help set the conditions for life in certain regions, and it can be defined as a volume of air defined by its temperature and water vapor content. So Washington's air mass is considered marine polar. That's it's cool and moist, and it comes from the Pacific Ocean. But Eastern Washington also receives continental polar air mass from Canada, and this is cold and dry. And so these air mass differences help explain why the eastern and western side of Washington look so different from each other despite being in the same state. Topography can be defined as the physical land surfaces and features. So some key elements to understand about topography are elevation, aspect, steepness, landform, and human structures. So an important topographical feature of Washington is the Cascade Mountains, and those have actually influenced the climate of eastern Washington. So when comparing western Washington's mesoclimate, which is marine, eastern Washington has a marine modified continental. So the explanation behind this is that the Cascade Mountains cause the rain shadow effect, which has greatly impacted eastern Washington's topography. So west of the Cascades, there is a marine-influenced climate, which can be described as moderate and temperate. And east of the Cascades, there's cold continental air. And as stated before, the explanation behind this is the Cascade Mountain Range. Essentially, it creates a wall which blocks heavy precipitation from the west, and the rain clouds that do reach the other side have much less moisture and precipitation, which explains how the west side of Washington is regarded as rainy and mild compared to the eastern side. The Kamiak Buttes' north and south facing aspects are very different despite being only a few hundred feet apart from each other. The south aspect experiences intense solar radiation, creating a harsher landscape for vegetation, whereas the north aspect is the opposite. It rarely gets direct sunlight, creating a much more rich environment for vegetation. Moving on to biomes, the Kamiak Butte falls into the category of the North American Western Interior Shrublands and Woodlands biome. Important aspects that make up a biome are soil structure, topography, solar radiation, precipitation, weather systems, and climate. And so this biome is found in Washington, Nevada, Colorado, and Utah. And so biomes really set the conditions for vegetative growth, and it's very common for um, regions of this biome to receive much less precipitation than others. And so in these regions, there'll be lots of shrubs, maybe no trees at all, or very little trees. When studying biomes, it's important to consider the anthropogenic influences. For this particular biome, livestock grazing has had a big impact on it. Um, Native species are at a risk of being consumed, and this will throw the system out of balance if that occurs. And with these native species being eliminated, invasive species are able to see more success. And some other anthropogenic influences would be wildfires and agricultural implementation, which includes the removal of native species to implement farmlands. The Kamiak Butte is not used for agriculture. Um, that's because of the thick layer of quartzite that's beneath the lowest soils. It makes it unfit for agriculture. So, moving on to the Kamiak Butte field report, this is more focused towards the contents of the Kamiak Butte, such as the tree species, animals, and vegetation, and a lot of the biotic and abiotic factors that the north and south aspects are faced with. As a result of receiving less direct solar radiation, there is a much wider range of species found at the north-facing aspect. Um, it has a cooler, moister environment than the south side, and so that has allowed three different tree species to grow and flourish here. They are the Douglas fir, ponderosa pine, and the western larch. These trees grow tall due to factors such as competition and space. So the average tree height is much taller here on the north aspect than the south aspect. So on the other side of the Kamiak Butte, we have the south aspect, and here this aspect receives intense direct solar radiation, which only allows certain specific species to survive. The only tree that can grow here is the ponderosa pine, and the ponderosa pine on this aspect is much shorter and more spread out than on the north aspect. Some other vegetation that can be found here is the Saskatoon serviceberry, snowberry, and the fescue wheatgrass. Some influencing factors to consider would be competition for resources, predation with deer, moose, coyote, elk, magpie, and decomposers. And so on the more abiotic side, we have wildfires. And dry spells leave the Kamiak Butte at like a particularly large risk, and that is because most of the precipitation that the butte receives is early in the year. And that's when much of the plants can't really use the precipitation because it's still too cold for them to take it in. So that really leaves the butte at risk of wildfire. Moving on to the fifth term report, we have carbon sequestration, and that can be defined as securing carbon dioxide to prevent it from entering the Earth's atmosphere. And trees play a huge role in this. They are very important to carbon sequestration. Um, and carbon sequestration has played a huge role in keeping the Kamiak Butte system in balance. So here at the Butte, there are three tree species that can be found: the ponderosa pine, Douglas fir, and western larch. The north aspect has all three of these, whereas the south aspect only has the ponderosa pine. So trees in larger abundance means that there is more carbon sequestration potential. So that's why the north side is assumed to have a much greater amount of carbon sequestration when compared to the south side, just because of the abundance of trees and diversity of trees. So on a field trip, samples were taken from the north and south aspect of the Kamiak Butte, with the goal being to compare the carbon sequestration of these trees on each aspect. And so the bottom line was that the north and south aspect, they showed similar basic results. However, the biomass of the north side allowed it to present much greater numbers of carbon sequestration than the south side. And that's largely because of the abundance of trees and the diversity of trees when compared to the south side, which only has the ponderosa pine, which is much more spread out throughout the butte. Um, yeah, this has been my term report number 7. I'd like to thank you for tuning in and listening.